Howdy everyone, Dr. Nir Regev here. So I've built this CFAR detection simulator in which I want to illustrate first how the CFAR looks like, and we will dive into how it's actually working under the hood in the next lesson. But as a part of the first lesson under the CFAR module, I want you to understand, to ingrain in you, why do we need CFAR at all? Why can't we just get away with a constant threshold? Okay, so as you can see here, we have this blue thing is the spectrum. That's the range profile. Okay, here are range bins or frequency bins in an FMCW radar. This is the CFAR threshold. As you can see, it changes itself throughout the spectrum, and it lowers where there is a target. As you can see, it kind of detected this target right now, and it didn't detect anything else. Okay, let's switch out of CFAR detection mode. Okay, off will be for fixed threshold, and you will see, let me go to the screen, and you will see that once I fix the threshold is flat, and a lot of detections are coming inside, right? These are called false alarm. This is the only target in the spectrum. Okay, now what we can do, right, if we are setting a threshold, a fixed one, we can take the threshold up. As we take it up, less false alarms are present, and we can find the sweet spot, so to speak, until there is no false alarm at all, just below the target. All right, so now we gain the advantage of, we know in advance, so to speak, what the noise spectrum or noise energy variance looks like, and we can set the threshold a few dBs above it, and we can detect this target. Okay, now why doesn't it work in real life? Because in real life, our hardware, for example, can heat up, and once the hardware heats up, the KT, the Boltzmann constant, times the temperature will generate a higher variance noise. Let's simulate that. Let's take this noise level and let's take it up, and now you see that the noise level is instead of 1, it's 1.4 now, and we have 2 false alarms, and we can increase it and we have more false alarm. If now it's cooling down and we decrease it, then we have less false alarms, right? And this way, in the fixed threshold type of scenario, we can't fight a dynamic process, which is the standard deviation or the variance of the noise. Okay, we can't have it fixed. So this is the motivation for CFAR. CFAR is a threshold that is set with the intention of keeping the false alarm constant. Now, there is more to it. It's not only keeping it constant, it's also maximizing the detection probability while keeping the false alarm constant. We will dive into the math in the next lesson. Okay, let's turn on the CFAR again. And now we can change, for example, the target SNR. We can make the target larger in terms of SNR. Okay, and we now can play with the false alarm. So we can set the false alarm. Let's take it to -4, to 10 to the -4. Okay, and you can see that the threshold now is going up. Let's take 10 to the -5. The threshold is going up, but still see, -5. Threshold is still going up, but look at the target. It's still in the vicinity of the target. It's lowering itself, right? We will learn why is that. Why is it behaving like that? But for now, we can see that the threshold is dynamic. It's adaptive. Okay, when there is high noise, the threshold will change. When there is low noise instances, the threshold will change accordingly with the low high noise, so to speak, and it's it's kind of working in the vicinity of peaks, okay, like in the neighborhood of peaks inside this spectrum. Okay, we can also run simulations. So here we have 512 bins, and we can run 100 of those, which will give us, I guess, some 550,000 trials all together. And if we run this simulation, there will be a report here. So it runs through the simulation. This is called a Monte Carlo simulation. And now the simulation results are here. The target SNR is 14.7. The number of trials is 100, but it's 100 spectrums. So there is like 50,000 50,000 even more bins, so to speak, to draw from. Okay, what's the CFAR parameters? We see that the guard cell, training cells, we will discuss that later. And we see that the target PFA is 10 to the minus 5. And let's see the performance. The detections, we have 100% detection rate. Okay, we didn't have any miss. The SNR is high, so we didn't have any misses, not in 50,000 draws. Okay, and the false alarm performance is we had one false alarm. The measured PFA is 2 times 10 to the minus 5, and the actual PFA is 1 10 to the minus 5. Okay, let's decrease the PFA. Let's allow more false alarm. So the false alarm rate is increased, sorry, not decreased, increased. Now it's 10 to the minus 2. And we can see here, even in our spectrum, there is more false alarms. Okay, let's run the simulation again. Okay, so again, the SNR didn't change, the noise level didn't change, the number of trials is 100, trials are 100, and we got our target 100% of the time. So PD is 100 for these 100 trials. If we trial a lot more in infinity, we will miss it. Probably the miss rate is 10 to the minus 6 or 10 to the minus 7. It's not enough for us to catch it. Okay, so PFA measured is 1.04 10 to the minus 2, and the actual PFA that we said is 10 to the minus 2. So we see that it's very close, right? We see how this threshold is actually preserving the PFA that we set. So this threshold is set using this PFA. It's a function of this false alarm rate, as we will learn. And that's the way we can control in radar how many false alarm we can live with, so to speak, and we will take the threshold to match this type of false alarm in the long run, so to speak. When we are sampling with a radar, it's basically infinite amount of time for false alarm statistics. Okay, we will learn more about it, but this code for this tool will be available for you guys to run it if you want and to play with it, to learn more about how CFAR versus a constant threshold works and why we need CFAR to begin with. In the next lesson, we will dive into the mathematics of CFAR, or of detections, of CFAR detection, and we will take the expressions that we need, the mathematical expressions that we need in order to see the threshold, and we will build a simulation. All right, so until next time, Regev out. Thank you.